It's not just what you know, it's how you write the answers that runs the whole show. Stay tuned.
Hey everyone, and welcome. So you're gearing up for your Class 10 board exams, and you know that in a subject like chemistry, every single mark counts. Well, today we're building the ultimate blueprint for Chapter 1, Chemical Reactions and Equations, to make sure you lock in a perfect score. Ready? Let's dive right in. So, let me kick things off with a question for you. What's the real difference between a student who gets a 95 and one who hits that perfect 100? Now, you might be thinking it's about memorizing more equations, but honestly, the secret is a little different, and it's something every single one of us can master.
And there it is. The big secret is presentation. It's all about communicating what's in your head in the exact way the examiner wants to see it. You know, so many marks are dropped, not because you don't know the answer, but because of tiny details in how you write it. And that's exactly the problem we're going to solve today.
So here's our game plan. We're going to tackle the 5 most crucial question types from this chapter. We'll start with those tricky why questions, move on to balancing equations, identifying reaction types, connecting it to the real world, and mastering displacement. And then we'll wrap it all up with a super simple checklist that's going to be your secret weapon in the exam. First up, let's talk about the why questions. You know the ones. They seem almost too simple, but don't be fooled. They're specifically designed to check if you really understand the core concept. And trust me, examiners absolutely love these. Let's look at a classic, a question pulled straight from your NCERT textbook that shows up in board exams again and again. Why should a magnesium ribbon be cleaned before burning in air? Just take a second and think, what would you write? Okay, this is where we separate the good answers from the perfect score answers. A lot of students will write to remove dirt. And hey, that's not exactly wrong, but it's vague. The high-scoring answer, the one that makes the examiner nod and give you full marks, is this: to remove the protective layer of basic magnesium oxide. See the difference? It's specific, it uses the correct chemical term, and it shows you know exactly what's going on. That right there is a 100-scoring answer. All right, moving on to our next non-negotiable skill: balancing chemical equations. Let me be super clear about this. You just can't get full marks on a reaction question if the equation isn't balanced. It's a deal breaker. And the whole reason we even bother with balancing comes down to this one fundamental law, something you probably remember from Class 9, the law of conservation of mass. It just means that whatever atoms you start with, you have to end with. You can't just create or destroy atoms out of thin air. No exceptions. Now, your NCERT book gives you a straightforward method for this, the hit and trial method. It's simple. First, just make a quick list of the atoms on both sides. Then, find the biggest, ugliest looking compound in the equation and start by balancing that one. You'll use coefficients, those are the big numbers you write in front, to get everything to match up. And please, always, always do a final double check at the end. And this right here, this is the #1 mistake students make. To balance the 4 oxygen atoms on the right side, it's so tempting to just change H2O into H2O4. But you can't. You must never, ever change the chemical formula of a substance. The only tool you're allowed to use is the coefficient. So the correct way is to put a big 4 in front, making it 4H2O. Remember that, coefficients, not subscripts. Okay, let's switch gears to our third section. A very common board question is where they just give you a reaction and ask, hey, what type is this? The secret here isn't memorization, it's learning to spot the patterns. You can almost think of chemical reactions like sentences. A decomposition reaction starts with one big thing, and it breaks apart into several smaller things. A combination reaction is the opposite. It starts with a few things that come together to form just one. And a displacement reaction is all about a swap. Once you see these basic structures, you can identify them instantly. Let's just zoom in on decomposition for a second. The official NCERT definition is your best friend here. A single reactant breaks down to give simpler products. That's it. One thing on the left of the arrow, 2 or more things on the right. Simple as that. And here's a textbook example, literally. This is straight from NCERT Activity 1.5. You take those green ferrous sulfate crystals, you heat them up, and they decompose. One reactant breaks down into 3 products. Oh, and here's a pro tip. Examiners love asking about color changes. So remember this one. The green ferrous sulfate turns into a reddish-brown ferric oxide. All right, on to section 4. You know, chemistry doesn't just happen in a test tube. It's happening all around us and inside us right now. Understanding how energy fits into the picture, whether it's given off or taken in, is a huge topic for board questions. Look, it breaks down pretty simply. Think exo like exit. Exothermic reactions let energy exit, usually as heat, so things feel warm. Respiration is a perfect example. And endo is like enter. Endothermic reactions need energy to enter, to get started, so they absorb heat from their surroundings, making things feel cold. Photosynthesis, which needs sunlight, is a great example of that.
So here's another one of those high-yield questions you'll see all over the place. Why is respiration exothermic? Well, the answer is pretty straightforward. When we breathe, the glucose from the food we eat gets broken down. That process releases the energy our body needs to do, well, everything. And because energy is released, it's an exothermic process.
Okay, we're on to our fifth and final major question type, mastering displacement reactions. Honestly, this entire concept boils down to just one simple idea: reactivity. It's all about which metal is more reactive.
You've definitely done this experiment, the one with the iron nail in the blue copper sulfate solution. So what's actually happening? Well, iron is more reactive than copper. It's stronger, you could say. So when you drop that iron nail into the solution, the iron literally kicks the copper out of its spot and takes its place. That's why the blue color of the copper sulfate fades away, and you get that reddish-brown layer of copper metal on the nail.
Phew, we've covered a ton of ground. So now, let's take everything we've talked about and distill it down into one final, super simple checklist. This is something you can just run through in your head before you write down any chemical equation on your exam paper. That's it. There are just three simple, non-negotiable rules. If you remember these three things every single time, you'll be protecting your marks and writing perfect answers. Here they are. Number 1, always write a balanced equation. It's the very first thing the examiner checks. Number 2, if the question asks for them, make sure to include the physical state symbols, the little S, L, G, and AQ. And number 3, our golden rule from before, you must never, ever change the chemical formula of a substance just to make an equation balance. Use those big coefficients only. So that's the blueprint. If you follow this and focus not just on what you know, but on how you write it, you're not just going to be answering questions, you're going to be giving the exact answers that earn those top marks. So, are you ready to write that perfect paper? Yeah, you absolutely are. Good luck.
Thank you for watching with us. See you next time.